Hello, and we're going to look at Unit 4, renewable energy sources. So, what are those energy sources we use that we can, call renewable? Which means when we use them, we can get it back really simple without using them up. All right, so let's look at what those things are. 4.2, generating electricity. So, how do we generate electricity? So, we basically, in Unit 3, you saw all non-renewable energy sources are ultimately used to form steam, all right, to turn the turbine engine on a generator to generate electricity. Renewable energy sources, energy resources, are used to do the same thing. In this assignment, you will look at specifically how generators generate electricity. So, there's your photograph or diagram of what a generator looks like. Okay, you have different parts to it. And as you can see, we get some spinning action to create some energy there, and we have some water flow, and we have some, that's called a, using renewable sources as we call water. Hopefully, that is. Um, Electricity is basically a discovery that changed the lives for everyone on the planet. Most of the things that we use each day would not work without electricity, of course. Even your cell phones, even though you think, oh, it's a battery, you have to charge those with electricity. Um, it's truly something we could not live without in the modern age, of course. BBCs generate electricities. This is basically a look at um, some type of oh, I got an error. Well, you can open that up. This is generating electricity, opens up in a new window. Of course, you can read that to learn how generators create electricity. So there's some more information. So in this unit, you should take notes, of course. And you have an outline provided for you in 4.1. And you're going to answer the questions below after reading the article shown there. So a little bit of independent stuff there. What we have here is Nikola Tesla and Thomas Edison, two gentlemen that are in I guess, the electricity wars, as some people call them. Who invented it? Which source was better? We have direct current versus alternate current, AC DC, going through. So we have that kind of some thought Nikola Tesla was the visionary, and Thomas Edison was an inventor slash businessman. So that's why he really got credit for a lot of things and popularity. You might hear of Tesla, the car, and that kind of thing, ran by Elon Musk. Uh, so that is something was named after him, I guess, out of respect for him and his legacy. And he should have got a lot more credit for it, in my opinion. So solar energy. Now we do have, how to generate electricity. We basically have a common thing that we look at to generate that electricity. So we almost like it takes energy or a resource to make energy. It just doesn't come out of nowhere, of course. And your general, and I know I'm talking and droning on about this, and I'm typing in the next slide here. Uh, and this is basically a how-to. And there's video sources on basically those kind of things. So from water, okay, that's say, hey, wait a minute, water is precious too, but you have some flow, and the question and answer. So we have this transformation of kinetic energy into electrical energy by large generators. Uh, the vast majority, okay, basically of electrical generation is produced through electromagnetic induction or mechanical energy through a turbine drives a generator rotate to produce um, electricity. And that's kind of how it is in a nutshell. All right. So generation is a process of generating electrical power. Okay. For utilities such as electricity power industry, it is a stage prior to the delivery to the end user as its storage or its storage. Okay. Electricity is not freely available in nature. It must be produced as our definition of energy. Even our own bodies use energy, but we have to produce it via breaking it down and using energy to get the energy. Now, the five sources of electricity, you have coal, natural gas, nuclear fission reactions, sunlight, wind, and hydropower. Okay, so that's, our traditional electricity does come from the coal sources, but we do have some water types of powers that And the two main types is hydroelectricity, generated by running water through thermal power, while thermal power is generated by burning coal, petroleum, and natural gas. Hydroelectricity uses renewable resources of energy, while thermal power uses non-renewable fossil fuels. Okay, so we have thermal and hydro as your two main sources, if you ever wondered about that. Okay, so 4.3, solar energy. Of course, it's the sun, and the sun shines, and we can draw energy from that solar energy, or we can call it heat source. And if you don't know, solar rays contain little photons that can generate some, electron activity. If you know anything about atoms, we have electrons in them. A photon will hit these receptors that we have solar panels and stimulate electron flow, which is, of course, is electricity. It's a flow of electrons. So solar energy is the energy from the sun, because the sun's energy is unlimited and is considered to be a renewable resource. So someday that won't be there, but is well past what our lifespans will ever be, because the sun technically will become some type of other star. In this lesson, you'll learn how solar energy is used to generate electricity. So again, this is 4.3, solar energy. Okay. So what is it? You're going to click on the image below. Okay. And you're going to go to the EIA Energy Kids webpage. This is in virtual SC. You're going to read all parts of the webpage on solar energy and take notes on your unit 4 notes outline. Okay, so I'm going to show this. I clicked it open, so I'm going to go share that somewhere else. And this is what it looks like now. Solar Energy Kids. Okay. It's a window within a window. Isn't that nice? So, solar basics, energy from the sun, collecting and using solar thermal heat energy. Uh, so we have these two screens. So you know what this looks like. Okay, you can go through there, and we use solar thermal energy systems to heat water in homes, buildings, or swimming pools, of course. Um, Inside homes, greenhouses, and other buildings, fluids to high temperatures in solar thermal power plants. You have the solar photovoltaic systems it talks about. Okay. Solar energy has benefits and some limitations. Okay, so what are the limitations? We know that it can be produced with limited air pollutants or carbon dioxide, and buildings have minimal effect on the environment. So energy has some limitations, though. What are those? The amount of sunlight depends on the time of day, where you are in the world. Some places don't get a lot of sun, as you might know. Same thing with wind or water. Okay. The season is dependent. The weather conditions, of course. The amount of sunlight reaching a square foot of the Earth's surface is relatively small, so the surface area is necessary to absorb or collect useful amount of energy. Okay, all right. So where is solar found and used? It's sunshine, and you can look at these different maps here to possibly gather some information on notes that are on your outline. Okay, and hopefully you are opening those now. We'll pause for a sec. No, we're not paused. That's just me. All right. So, solar thermal collectors, I have concentrating collectors. What are these? Well, um, this is kind of the way we use it and how we use it. We have photovoltaic cells, um, and that kind of thing to capture or use the sun. This is a description on how solar photovoltaic cells work, convert sunlight into electricity. Photons carry solar energy, and so on and so forth. Okay, so it talks about the flow of electricity from solar, how photovoltaic systems operate. Okay, so it goes. This is a long outline. All right, and they have solar thermal power plants where you can technically store and concentrate that energy. Okay, so you have different types: linear, solar power towers. I like that. That's pretty cool. Solar power towers. All right, and we have solar dish engine systems. Okay, so we're getting better at this stuff. When I was younger and your age, this stuff was around, but not as advanced as we have today. Okay, so this will go on and have solar dishes that you can see here, thermal collectors and storage. and those kind of things. And it describes how these pieces of equipment are engineered, manufactured, and how it is used, um, and how the environment is affected. Now, based on just having these raw materials, we're using resources to make it to get resources that are renewable and saying we're not affecting the environment as much. So you can imagine the discussion we could have about, is the solution better to use than the problem it may cause? Okay, so this water was brought to you by water. It tastes like water. I like that, don't you? So that's kind of what you're looking at. That's the discussions you can have. But you can't have the discussion unless you know the facts about, okay, this is how much materials we're using, this is how much actual natural resources we're creating these photovoltaic cells and plants, and are we really not emitting carbon dioxide in the production of these things? These are all things that you can think about. Like, oh yeah, finally we found a source of energy that isn't going to harm the planet. Well, does it cause any harm? Is it just harm free? Okay, so that's what you're looking at. Okay, so back to our presentation. All right, so part two, that was part one. See that, part one, what is solar energy? All right, so how do we use it? All right, so the following videos, which I could not get a link to, and I won't show a video within a video, that is in your virtual SC in unit 4.3 section. Pay attention to how excess electricity formed by solar panels in a home can be sold back to power companies. Interesting. And then you can answer the questions below after those videos. So do that. Part three, solar energy power plants. This is part of that video. I'm sorry, the handout or the read article that you saw. Can be also solar energy power stations in several forms. One problem with solar energy has been finding a way to share the energy. Okay, so the video in your virtual SC shows a solar power station in Australia. It's designed to store the sun's energy in molten salt, so hot salt. The second video is a computer animation of how the energy transformations lead to the generation of energy. Watch both videos and answer the questions below so you can see how this goes. Section, little paragraph here. I explain something, watch the video, answer the questions in virtual SC. Pretty basic concept. And now we're on to 4.4, wind energy. That took a lot of energy for me to do. My lungs are not that good, even though I swim and play basketball and run and things like that. My lungs have always been the least strong thing in my body, besides my, injured knees over years of basketball. So, 4.4, wind energy. In this lesson, you'll learn how wind energy is harnessed and converted into usable energy to meet public energy demands. So we can combine this with other forms, as you can see. We're not going to just go to one yet. Wind, solar, nuclear, and those other ones that I'm missing, hydroelectric, those kinds of things we can all use sparingly, and probably in different parts of the country, it's more effective. I drove up to Chicago from, of course, where I live now in South Carolina, and you drive up through Indiana, and there's crops and crops of corn, huge, youngest, farther than the eye can see. It's amazing. My wife, who has never been in the Midwest, took pictures of crops and cornfields. So anyway, I've seen this stuff before, but the thing that alarmed me was these massively tall, alien-like looking spaceship things that were just twirling around for miles and miles. It looked really creepy and almost like a, really, M. Night Shyamalan movie. So basically, what you're looking at is some massive things that you've never seen. It's also in the oceans as well. Sounds like a good place to put it. A lot of wind through the oceans, not a lot of trees stopping wind, or any mountains getting in the way. Okay. So part one, using wind to generate electricity. So wind energy is a clean source of energy, and the use of wind energy is growing all over the world. Okay. So yeah, but we're looking at protecting the environment. Are all these pieces of machinery and large things and the factories to produce them kicking out gases and things like that to produce and using the energy that it takes to make them? Is it worth the problem? Might be, depending on their gas emissions, or is it just another alternative that we love to have choice and it doesn't affect anything at all? The Gaia theory, as you might learn later in this course, is states that if you want to look up the Gaia theory in environmental science, do that now. Of course, you can press pause at any time. All right, so wind energy does not produce any air or water pollution except for the making of them. And most wind energy comes from turbines. Okay, so it spins through the wind instead of water and or other electricity sources. I'll read the article Wind Energy Basics. Okay, Wind Energy Basics. All right, so I'm going to share this, hopefully. And this is what it looks like once you click on the link in Virtual SC. Not my links. I don't share these PowerPoints. But I can. I just don't want to because it's for you to. It's already been done. It's on Virtual SC. All right. So basically, you're looking at the source of these guys. It's what the energy.gov. It's the I get calls from the government all the time to say, hey, do you want to switch to solar? And I always think about it, but the focus of the time I have right now, would I be able to really make a sounded decision? And think I can. Once called windmills. Okay, so this technology has been around for a very long time. Okay, Don Quixote was fought with. So anyway, used to harness power, of course. Over the past 10 years, the United States has been increasing their wind power capacity. It's been 30% more. And when's this? You have to see the dates on these things, which I can't locate right now, and I won't waste your time doing that. Wind turbines, as they're now called, collect and convert the kinetic energy from wind moving the propellers into electricity to help the power grid. So we're feeding the power grid, so we're not have to be dependent. And how long do these things last? And how long And you're saying also, let's think about this. Um, we're putting those things in the environment, in the ground, in the oceans. Now, the oceans are unique in the fact that we're saying coral reefs are being destroyed and stuff like that. But you put these pieces of metal in the ocean attached to the bottom of the ocean. If they do it that way, there's two different ways. One bobs and one actually is attached to the floor. Um, Coral life and other life pieces in the ocean will grow on these things. So technically, you're still having other surface areas for things to live on, which is interesting to me because it takes care of it's not really harming that much. All right, so back to wind energy. Okay, the sun's uneven heating. Okay, there's Earth irregular surface, mountains and valleys, planets' revolution around the sun all combine to create wind. Since wind is in plentiful supply, it is a sustainable resource for as long as the sun rays heat the planet. In addition, because wind power is a growing industry. Okay, this adds jobs, so that's positive, right? Let's look at the positive and negative. If you're going to debate this, I'm not going to tell you what the answer is because really, I mean, it's all up to the greater good. Look at this number: 41 states have created more than 100,000 jobs for Americans. So if you multiply 41 states, and you're saying, okay, the economy is booming, and no, I can't say that. 100,000 jobs. Okay, that's a lot, a significant amount. Right. Now you can learn more about how turbines work, distribution, advantages, wind energy throughout history, current research. Those are all things that are interesting to learn, especially if you're a history person. How far back does this stuff really go? You know, and you can look at that. Okay, share this tab. And this is basically, 1850. This is recorded history. Okay, so look at that. You're generating stuff. Okay, so we'll go back to our presentation or not. Okay, let's share this in a different way now. Present a tab. Do it this way. So that's part 4. Okay, those are your wind energy basics. I'm sorry, Let me restate that. It looked like four. It's 4.4 part one. Part two, I'll move along here. Advantages and disadvantages of offshore wind power facilities. I touched on this in the discussions I've been blabbing about in the last, three sections here. Is it good? Is it bad? Basically, you're saying, oh, better than this, but not as good as that. But is it better? You know what I'm saying? It's that kind of discussion. And which pieces of information would you use to support your point of view, and why do you have that point of view? Why is it biased towards this rather than nuclear or water or wind? It probably is dependent upon where you live in the country is regionally based, or it could be, it should be. I mean, if you live in a desert, you probably don't want to advocate for water power, hydroelectric power. But that's all determined by can we ship it to there? No, I'm not going to discuss that. That's a huge engineering thing and civil engineer. So, what are the advantages and disadvantages of our offshore wind farming? This is really cool. Some of these things you probably didn't know happen, and these massive undertakings of planting these things in very open seas that are dangerous. Actually, you look at the North Atlantic or the offshore of England and the canal, and it's basically some massive stuff to see. You really got to look at that. Look at some of your arguments for advantages and disadvantages. So you are basically educated in the topics that I kind of touched upon. Get some depth and some substance behind what you think. And people will still argue with you, even if you have a lot of substance to it. So just be aware of that. Okay. Part two. Okay. Advantages and disadvantages continued. So, what do you see as the major benefits and drawbacks of offshore wind stations? Okay. Do you believe in South Carolina investing in an offshore wind station or wind stations? Support your opinion of evidence from the article. So, this article and the pages before, get this one open and see if you can pick those out. And which one do you lean towards? List the major benefits, and this is how you're doing this step by step. You have to get these points, each one of these, each bullet point. So, first, for 1 point, list the major benefits of offshore wind stations. The second point on that one is list major drawbacks of offshore. Do you believe South Carolina should invest in offshore wind stations? That's another point. An opinion is not opinion supported with evidence from the article. You have to have an opinion. No, I shouldn't. Okay. Why do you think that? What did the article say, and why do you think that, and what's your opinion? Not necessarily in that order, but you're getting the gist. You have to hit on all these. And a lot of the assignments, not a lot of them, but sometimes I get an assignment with these writing prompts, and something is missed. Like there's no citing. It's usually not citing the article. It's just stating what you think off the top of your head. So you don't. Maybe it's your, whatever. So let's just look at this. 4.5. That was 4.4. You had two parts to that. Very short section. All right, so now 4.5, hydroelectric energy. So hydrogen and water, hydrogen, oxygen, water. It's, the slip and side thing. How do we get that? Okay, so energy is produced as water moves through a dam, causing a turbine to generate electricity. In this lesson, you'll learn how hydroelectric dams create usable energy. So it's basically, if you were to become an engineer, how does this work and how would you make it better? I'm not going to open this up for you. Possibly, I might think about it, but various components in the hydroelectric power plants. It's the article, and it's basically what does it take to build one of these things, and how does it work through it? Of course, the engineering and process. We know the theory. Water flows, turns things, and it generates electricity. All right. To determine the steps, you have to read the article that are necessary to occur in a hydroelectric dam to create electricity. And boy, oh boy, do I love opening these things and reading them to you. Okay. Yeah, that's damaged. The link is damaged. Isn't that awesome? Love it. Love it. All right. So, hydroelectric energy, part two. All right. So, the types of hydroelectric dams. Part one was how does those things work? And types of dams that exist. We have the Great Hoover Dam out west, and other dams do exist, even in Great Falls. Duke Power has a dam in this area. So the picture, you're going to study the picture and read the first 6 paragraphs in the article. So pay attention to that. You don't want to read the 18 million pages that it might have. Now, on storage and run of the river dams below and answer the questions. Let's see if this one opens up safely, and it will. So you're going to get this type of an article, and you're looking at 6 paragraphs worth of information they want you to be aware of. Now, look how these things are there. And really, if they build homes in these valleys here from the dam and this breaks, well, you're in trouble. 1, 2, 3, 4, 5, and 6. Not bad. And you have types of them. Okay. So, what is the takeaway from this? There's more than you think involved with dams. Just gotta build a huge wall and have things run through it and create electricity. There's other aspects to this. Okay. Now we have different areas of the country that would probably construct large ones, small ones, or whatever. But just for kind of read the types of hydroelectric projects within the Northwest, hydroelectric projects can be generally be placed in 2 major categories: storage and run of river projects. So the river runs, and that's how that projects energy. All right. So I kind of belabored that point. Okay, so back to the crux of the matter, which is 4.5 still. And that is going to be what? That's going to be your types of hydroelectric dams, which we just looked at that article real briefly. Okay, I'm going to present my screen. So that's what we're looking at. And I'm going to go jump right to 4.6. So notice there's a title thumb on that one. Now, in this lesson, okay, I'm going to stop presenting real quick on this one. No, I won't do that. In this lesson, you'll learn about a few things. Okay, it's biomass energy. Remember, 4.6 is not the last one, of course, as you see on your calendars or your schedule or your virtual SC. Go ahead and present this again because I just like to. So in this lesson, you'll learn how burning of biomass yields usable energy. So in this pinwheel here, you see all the things that we consider biomass. It's a mass of plant or dead organic material, if you will, that you can burn to yield usable energy. So it goes into a heat source, basically. This is biopower, living things. Technically, it's going to be dead when you do this, but how do you use this energy, this massive source of energy? And how does biopower work? Read the article, and then you answer the questions below. So what does the article state? Of course, there's an error on it. Why would there not be? Okay. So, and basically what you're looking at is, for example, you have a corn crop. You've heard of ethanol. That's basically taking corn, refining it into a source of energy like a gasoline, petroleum. So gasoline now, usually, probably 99% of the time, will have a form of alcoholic fluid that comes from corn, ethanol. Okay. OL is your key to saying it's an alcohol. Um, and it's about usually 10% of straight gasoline, and it's usually a combination. So it's almost, and there's some drawbacks to using ethanol. I don't know if people really realize, oh, they're putting good fuel in there, so it doesn't harm the environment as much, and we're using other things rather than crude oil sources. Well, ethanol does have an issue with engines, and it does tend to break down things a little faster as far as the metals and things like that. So some good things, some bad. Some people do seek out the old guard of folks that still are around. Remember the old days of straight gasoline? They still kind of hunt for those. There are some gas stations that still exist. I've seen them. They might not exist anymore, but I've seen some of them. And that is really quick. 4.6. Answer the questions. They don't talk much about that. The article is kind of big though. Okay, this last one, geo, which means earth, thermal, heat, energy. So it's heat from the earth. We basically sit on top of the crust and there's heat coming off the earth. And mostly it can be heated from external or internally. So geothermal energy sounds like a really easy way to, get some some really renewable resources. You're going to learn in 4.7 how geothermal energy is converted into usable electrical energy. Okay. Geothermal power. Now you have a video here um, on how geothermal is being used in parts of the world to generate electricity. Okay. Use your outline, take good notes. Um, and there's a video course you're going to use. Okay. So what, kind of, you're going to think, okay, I can watch the video, Coach Powers. Don't drone this thing out. Of course, you can skip ahead if you wanted to. But what you're looking to do is, I don't think a lot of people know what geothermal is and how do we get it. If you do, let us know. No, I know how it does. Of course. So geothermal energy sources. All right. So if you watch the video, you can stop this or just watch it while I'm talking. Basically, it's a electrical power generated from. Okay, that you know that. Basically, technologies in use include dry steam power stations, flash steam power stations, and binary cycle power stations. Now, geothermal energy electricity generation is used in 26 countries, while geothermal heating is used in 70 countries. That's a lot. Okay, basically, it's heat within the Earth. So your Earth's core has hotness. All right. And it's a renewable because our Earth hopefully will be hot for a very long time, not too hot because we don't want the oceans to stop. That's a whole nother lesson upon how the ocean's currents work. Okay. So the best definition, I guess, is produced or permeated by such heat as steam geothermal regions. Um, excuse me, I'm talking way too long. Geothermal is a type of renewable that it takes from the Earth's core, as I said. It comes from heat generated during original formation of the planet and radioactive decay of materials. So that gives off heat. It's like any reaction where decomposition happens, you might take in chemistry. A reaction happens, sometimes heat is given off, sorry. Um, this heat, thermal energy is stored in rocks and fluids in the center of the earth. And that's how things happen. Reactions happen, big bangs and combustions and radiating heat and stuff like that. And there's different classes of thermal energy. Okay. What do you mean by that? Well, rocks at some depth below the surface of the earth are very, very high. This comes from the fission splitting of radioactive materials, which are naturally present in these rocks. All right, so there's class 10, that'll be classified as that. There's class 7, for example. It's um, how much it emits from these rocks. Okay, the steam is used to run turbines. You might see in Yellowstone the geysers they have, and things like that. There's a live, by the way, if you look online, there's a live camera access to Yellowstone that will, you know, record anything going on, and sometimes it records the geysers when they shoot up. All right. So make sure you look at the video, take notes, and now that you watched it, read the article, and then I'll show you how the power plant generates electricity. Okay. Now, what does that look like? That's your article and the text version. This is kind of wells are drilled. It's kind of a step by step here. It's really nice how they do this. Steam turns the engine. Turbine drives the electrical generator. Transmission, the power lines deliver electricity. So generating electron flow, basically. How are we going to do that? In this case, it's energy from steam moving things around. It's almost like hydroelectric energy. It's kind of close to that because certainly steam can be some form of liquid turning into an evaporated gas. Might not be water though. All right. That makes sense to you? That's sinking in? All right. So here you go again. The advantages and disadvantages. Is it legit? Is it no bueno? All right. So What are you going to say are the pros and cons? I gave you a lot of information about the previous topics about the pros and cons. What can possibly be wrong about taking just natural energy from the earth? Well, guess what? There's arguments about that. And this is your article saying that from that link. It's in Virtual SC. Okay. And it tells you again what it is. And it says the pros and cons. Now, the list is based on ways we harness it: electricity generation with geothermal power plants and geothermal heating and cooling systems. Now, the basis of the disadvantage seems to always have any issue with the usage of land, natural resources to build those power plants and build those structures to gain those. You're interrupting the natural environments. Um, they're saying it's environmentally friendly, but there are some environmental issues. It's renewable and sustainable. Yeah, I can give you that, but why? Tell me what are the information you see here and is the most important you pick out that triggers in your mind to say, okay, that says it. Don't just pick out one thing and say, I'm going to go advantages. All right, you got to see both sides of the equation. Being one sided without seeing the other options on the con side would be short sighted and very narrow minded. To know that everything that is just, you can't say everything's perfect. Okay. Now, they give you pretty much a lot of your argument, of course, thank goodness. Pros: does not cause significant pollution, although they didn't say no pollution. It's renewable and sustainable, or is it? If it wasn't, we wouldn't have. Well, hopefully it always is. This water brought to you by water. It creates hydroelectric power. Massive potential. Massive. Why isn't it massive already? Reliable. Okay. According to other sources, not just, it's never, nothing's ever 100% reliable. Great for heating and cooling. Okay. Right. Some minor environmental issues. Well, yeah, you can't just state that, but what are they? I mean, these are great things to say, but what do you mean by that? Some of them. Okay. Location specific. Yeah, it has to be. You're right. You have to have a place where that steam is coming off of the earth. Now, this is a huge drawback. It can cause earthquakes in extreme cases. Yeah, danger zone, man. I mean, talking about hazard pay. Um, Basically, high initial investment, or basically getting into it. There's some initial costs. That's why solar power had trouble starting with different plants and things like that, because of the high investment costs going into it and upfront costs. Okay. Do you know the numbers according to that? And what do we consider initial costs? These are some things you have to think of as scientists or even financial advisors, or getting more information, more substance behind your argument. It just costs too much. What do you mean by cost too much? What kind of initial cost do you think is too much? Is it economically sustainable by the company that's trying to manufacture these things? All right. So, what is geothermal energy? Heat produced by magma is a massive source of energy and can be converted into electricity. Okay, magma. Right. So volcanoes, basically, yeah. That in itself should say, okay, yeah, let's go build a plant, hang out by a volcano where molten rock is, and molten hot magma. All right, very hot, hotter than even than the surface of the sun. Okay, that does look cool. I've ever seen pictures of running magma. It's really neat. Now it does break down these words for you. Why is it environmental friendly? There's some pieces there. Why is it renewable and sustainable according to what we have found or say? All right. So saying what they mean is they will last for millions and billions of years because it already has lasted for 4.6 billion years. Massive potential. That's the one that you probably say, what does that mean? All right. They're talking about 17 terawatts, TWs, not Time Warner, of power. A light bulb has maybe 60 watts. You multiply that by tera, you know, that's actually a pretty good, relation, because Terra, Earth, terrain, but it's a multiplication of power of 17. Okay. Um, there's actually many times more energy that's stored inside the earth. So we're not harnessing the 100%, like they say, you know, with other things that we're using, we're only tapping into the surface of it, literally. All right. Geothermal power plants across the world currently deliver 12.7 gigawatts. All right. It's stable. We can predict the power output with remarkable accuracy. All right. So that is your other pro. Great for heating and cooling. You can see here has a heat and sink source slash source. Yeah, I'm not going to go into that too much. That's for your perusing in the link from Virtual SE. What are the environmental issues and disadvantages? Abundance of greenhouse gases below the surface. When it's used, some of these gases escape. No, that's some environmental issues, and we're trying to get non-environmentally bad. You know, so what kind of toxins are in there? We have some mercury, arsenic, and boron. Not boring, boron. All right. So arsenic, hugely poison to humans. If I'm not going to give you ideas, but there's a good movie back in the old days about that. All right. According to the Union of Concerned Scientists, so these scientists are concerned. It's like a union of concerned scientists. All right. Pollution associated with geothermal power is low and just a tiny fractions of what we see from coal and fossil fuels. So right now they're saying there's a generated advantage. Okay. So, but be very critical about the information you're getting also. So, how, look at the name of the company here or the website. It is a blog. Where is it from? Who's saying it's a .com? They might be actually trying to spin you on something. So be very careful. Even though Virtual SC and I have provided you with this information, always be critical, cynical. That's a bad word to say, but think about, okay, where is this coming from? There's some surface instability, right? That has happened already. Sinking of the Earth's surface in Germany and New Zealand. There's an island near New Zealand that had a huge under or submarine volcano recently within the last month that pretty much submarined an entire island and created something new. And that's, if you want to look at that, I think it's the Tonga off of near New Zealand. And I'd have to go look that up again, but it's flashing in my mind as I talk about it. Now, the construction of a geothermal power plant in Switzerland triggered an earthquake with a magnitude of 3.4 on the Richter scale. That's kind of the mid ground, almost getting up there into, okay, that's huge. The 4 and the 5s. Okay, expensive. Okay, here's a definition of expensive. Total initial installation costs usually end up somewhere between 2.5 to 5 million for a power plant of 1 megawatt. Is that worth the investment over time? That's the capacity, not what it generates overall. All right. So there's a lot of upfront costs. Okay. So the ground source heat pumps typically cost 15,000 to 40,000 install and generally have a payback time of 10 to 20 years. So if you're sinking money into a power plant using this type of energy source, geothermal energy, you're going to have to get an ROI, as they call it, return on investment, in about 10 to 20 years. Hopefully, okay, unless you're something goes wrong, you don't know. You have one of these events, instability, earthquakes, the expense kind of changes. All right, better have insurance too. Location specific. All right, so reservoirs are hard to come by. Some countries are blessed with a great resource. Iceland and Philippines, for instance, they meet 1/3 of their electricity demand. Okay. Geothermal energy is transported, if it was, by means of hot water, not electricity. Significant energy losses had to be taken into account. Basically, water does cool over time. Think about that one. Sustainable issues. Sorry about that. I'm the throat getting raspy over an hour of doing this. So rainwater can seep through the Earth's surface and into the geothermal reservoirs over thousands of years. Reservoirs can be depleted if the fluid is removed faster than it's replaced. So you can technically suck it dry. So it's contradicting the renewable part of this whole thing. But we do have the ability to replace it if you just stop using it. But there goes your investment, or part of it. Time is money. Efforts can be made to inject fluid back into the geothermal reservoir after thermal energy has been utilized. Sorry. Geothermal is sustainable if reservoirs are properly managed. So now we have some verbiage here that kind of pokes some holes into its renewable. All right. Technically, everything is renewable over time. Okay. My intelligence can be renewable. I've lost it long time ago, or my sense of humor. It's gone. It might come back. I'm not funny at all from what I know. Now, the ending here: geothermal, a clean energy source held back by high upfront costs. The bottom line is this. Here's the bottom line. Geothermal energy is generally regarded as environmentally friendly, sustainable, and reliable. This makes geothermal energy a no-brainer in some places, but heavy upfront cost stops us from realizing full potential. Give us money. How much influence geothermal power will have on energy systems in the future depends on technological advances, energy prices, and politics. No one really knows. Okay, so let's you have some more things here, some key takeaways. I'm not going to kill this to death here, but this is the gentleman that has written is the author. You might want to do some background checking on this gentleman. Okay, and who is the company? Can we find them? Solarreviews.com, all rights reserved. I can't really about us. Contact. Who are these folks? So if I clicked on that. Okay, so we have some locations there. We can get some more information about who and what they are. All right. And really, there's a non-distinct tie into a company that I can find. I don't have time on this video in front of you all to see, okay, what company really is pushing this. Might be Duke Energy. Okay, but it might not. Okay, so it looks like a college source. But I can do some review. I mean, maybe you can do the research for me and say, hey, Coach Powers, this is what company is generating this. And they want you to register too. So there's possibly some financial gains. You got to be very careful with the information. They might be actually a solar company that's saying get away from geothermal energy because we want our solar panels to be used. And I apologize to this website if you have no, if you're fully altruistic and have no, financial gains from this. As you can see to the right, it's a huge solar energy push here. Hate to expose something, but sometimes you have to be a teacher and make sure your minds are exposed to what should be thought of. It's like buying stocks. You don't want to go to a website that's pushing a particular stock just because it wants to get your money on it to see if it can inflate the valuation of it. And if you don't know what I'm talking about, we can have these discussions on office hours. It's fun for me. People say, Coach Powers, you're nuts. But there's a lot of aspects, and people get really tired of saying, well, Coach, just say it's good or bad, please. No. Frustrate the heck out of people doing this. Can you imagine what my family says about me at the dinner table? It's ridiculous. Can never give a straight answer, right? All right. Exists in massive amounts under the Earth's surface. Generates electricity by drilling underground and tapping into the resources. It's actually not a great thing all the time. Takes advantage of temperature differences below the ground. Pros, cons, again, and geothermal has potential to become a major global energy source held back by high upfront costs. So we're saying, solar doesn't. All right, so I'm stopping there. I'm stopping the, high investigation of that. Back to our presentation here, because I know that's what you're all here for. All right. The expansion of your minds. So, have we come up with, is it legit? Is it no bueno? Is that energy, is that source of information non-biased? It sounded okay, but does it have any solar pros and cons? Of course, I bet you it does. All right, so here's your energy decisions experiment 4.8. 4.8. Yeah, make sure that shows up so I can chapter it on YouTube so you guys know if you want to go to a certain section. What does Coach Power say about this? Well, gotta know. Um, so in this assignment, you'll have to make decisions on what types of energy resources to use to power a community. You can already think in your mind, okay, the Sahara Desert, I'm going to use some solar stuff. Do you have stuff to transport it to the Sahara Desert to get it there? The cost of getting materials and blah blah. Once you make your decision, deal with the pros and cons to make your constituents, that's usually political, happy with your decision. This will give you the opportunity to see the various pressures that community leaders face when making decisions on energy resources. Remember, as a leader, making decisions, hopefully with a committee, because then you can get all the pieces of information you need to make a sound, educated decision. And you'll say, okay, here it is. And there's going to be a group of folks that say you did not make the right decision. Just be careful of that because you will get it no matter what decision you make, even if you're deciding on what to eat that night. Or, there's going to be people that you're eating with that probably say that's a bad decision. No one's ever 100% happy. Seems like that, right? That's pretty true. Before you begin selecting, identify the possible problems you may face or pros and cons of the resources you're selecting. So you have some options in this unit. What are the criteria you are setting for your choices based on the community? What are the constraints you expect to face? You have to hit all these points. Pros, cons, criteria you're setting for your choices based on the community. What are the constraints you expect to face? So based on your community, where is the community? What type of community? What kind of population do you have? Can you get it there? Expense, taxes, possibly factoring in. If you live near a geyser or an area with geothermal access, then you might want to just use what's there. You know, that's kind of how we go about these things. Now, that's seven. That's six. I'm sorry, seven. What were your final energy sources and percentages? What was the response of the general public, the business community, the environmentalists, and the government to your solution? Were you able to make everyone happy? Okay. What were your final sources and percentages from your lab? What was the response of the general public to your solution? What was the response of the business community? What was the response of the environmentalists to your solution? What was the response? So each one of these things you have to hit. And I'm going to probably tell you the last one. Was everybody happy? Yeah, good luck. I don't know. I mean, I don't know. A perfect world doesn't exist, maybe. Okay. So stopping on that one for this page for a second. If you have any questions about these sections or these labs or whatever question it may be, office hours, Monday, Tuesday, Thursday, unless otherwise stated, please do that. And it might be different in this semester if I'm using this video over again. All right. So, 8. As you considered your possible solutions, you probably identified a solution that you thought would be the best and apply that solution first. But you have to go back and say, nah, it didn't work out. Hopefully you get that opportunity. What was your first solution the best? How did you confirm? How did you find the best solution if it was not? All right. So grading guidelines number 8. What was your first solution? Was it the best? And then how did you find your best solution? That's 1.5 points. How do you confirm whether it was the best solution? I give you some of these questions. Number 6, you have to select the pros and cons of what you're selecting. Number 7 kind of deals with what was the result of your decision. And number 8 deals with what was the process for you. Okay. The whole process, kind of an overall gestalt of this is how it all works. What does it all mean, man? All right. So 4.9, you decide. Let's talk about it, man. I mean, you decide. 4.9. This water segment is brought to you by water. Water is what's for dinner. 4.9, you decide. Over the past 2 units, you've learned about types of resources. You also learned about the environmental benefits. Hold on. All right, 4.9, take 2. You decide. So you're acting like the leader in South Carolina. You're looking at 4 primary energy resources that you would recommend in South Carolina. So you're the leader. You're making the decision. You're going to post your answer in discussion in 4.9 and virtual SC. You're going to read the article first. So you'll look at basically the direction state in the last 2 units, 3 and 4. You learn about the environmental benefits and consequences of using different types of resources, as well as some conflicting opinions. In this assignment, you'll read the article again, not the same one we read before, but a different one, and look at the available resources that aren't part of the country. So it's dealing with South Carolina specifically. And you would recommend some future energy uses. So you're going to think about identify 4 primary energies. That's number 1 that you would use or recommend in South Carolina, and explain why you would use those. You're going to post your answer in discussion. 10 minutes after you post your response, you'll be able to see your classmates' answers reply to at least 2 classmates to get the full points. Explain whether you disagree or agree. Make sure your response are meaningful and respectful. All right. Those things are recorded. I've gotten some reports in the past. So here's how I will grade them. I'm pretty, good at, understanding how you've written something. So you have to have 4 points worth of a 4 resource. One resource, energy source, you get 1 point. You get 4, you get all 4 points. Your answer has to, or your discussion post has to explain why the 4 resources should be used, citing data about the pros and cons of resources and data from the tutorial about the availability of resources. That's up to 5 points. Okay, you have to cite these things. Okay, don't just post stuff. Respond to peer 1 with respectful, meaningful responses, up to 3. Respond to peer 2, up to 3 points. So depending how good it is, I might give you a half or 1 point out of 3. So make sure you're doing these step by step. I'm starting to get a little more um, tough, I guess, for lack of a better word, at looking at these and deciding whether these things are worth all the points. I've been very easy grader so far. All right, now you're ready for the 4.10 Unit 4 test, and you're all ready. So make sure you do each section, study the notes, go through and ask questions during office hours. You guys are doing a great job. Keep it up, and we will see you when I see you.